Good morning, students. My name is Ashish Saran, and I have done my dual degree in mechanical engineering from IIT Mumbai. I have been teaching for last 17 years, more than 17 years now, with some reputed coaching institutes. So today I am going to take a topic which is a very interesting topic actually, from the point of view of starting of physics, application of vectors. So the topic is two-dimensional motion and projectile motion. So how to start the topic? First, I will take an example. Let me say I have a body and the body is moving like this with some velocity, let me say u. Now with this velocity, initial velocity, I apply an acceleration here like this. This is my acceleration, this is my initial velocity. So coordinate system can be selected like this. Now I will resolve this acceleration in two components. One is along x axis and the other is along y axis. So now because of this component ax, its velocity in x direction will change. Its velocity, initial velocity in y direction initially is 0, but when this acceleration plays some role, it will increase its velocity in y direction also. So let us see what is the effect here. Vx equal to u plus ax into t and Vy equal to 0 plus ay into t. So for this equation, initial velocity in x direction is u, final velocity in x direction is vx, acceleration in x direction is ax, and my final velocity in x direction will be given by this equation. Now let us take a look at this equation. Final velocity in y direction will be given by this equation. Let me say the body after some time reaches at a point, let me say x distance along x axis and y distance along y axis. So its x coordinate at any time interval t will be equal to x equal to ut plus half ax t square. So this is x displacement at any time instant t. Let us find out y displacement at any time instant. Y will be equal to half ay t square. So these are final velocities in x and y direction respectively, and these are coordinates along x axis and y axis after any time instant t, time interval t. Now this motion, we can see this thing here very clearly, that x coordinate is changing with time, y coordinate also changing with time. So this particle after time, let me say it is here in the starting, after some time t it may be somewhere here or maybe somewhere here. So both x coordinate and y coordinate are changing. So this is an example of plane motion. If x coordinate only changes, or y coordinate only changes, then it is not a plane motion, it is a linear motion then. So we are trying to take a look at what is plane motion. In plane motion, any two coordinates, maybe x coordinate and y coordinate, or y coordinate and z coordinate, or z and x. Any two of the three should be changing simultaneously. Then it is a case of two-dimensional motion. So now projectile motion is a very interesting example, very commonly available in nature of two-dimensional motion. Now let us take a look. Let us go to the projectile motion now. Let me say this is my origin of the system, x axis and y axis. A body is thrown from here. Let me say with some velocity u. Like this. Then from here, let me say this angle is theta. This is my initial velocity u. This body will take a path like this. Like this. So this path, body starts from here and lands here. This distance is horizontal range of the projectile. This is maximum height attained by the projectile. The body starts from here, lands here, and let me say the total time it takes is t to land there. I will resolve its initial velocity like this, ux and uy. Ux is nothing but u cos theta and uy is u sin theta. So because of this velocity ux, the body moves in x direction. Because of this velocity uy, the body moves like that. This velocity ux remains constant. Because we are neglecting air resistance here. We are assuming that body is traveling in vacuum. So whatever initial value of this velocity is there, it will remain just like that at this point also. Let me say at this point also. However, this component keeps on decreasing as we go higher, and once we reach here at this point, uy becomes 0. Once we go beyond that point, it starts increasing again. So let us take a look here. This is this length and this length are equal. So ux, here also ux, here also ux, even here also ux, and this component, let me say vy. Here let me say vy. And at this point it will attain a value equal to the initial value, so uy. So the angle at which body had taken off, it will land at the same angle here like this. It was thrown at an angle of theta and it lands at an angle of theta, and so on in this figure here. So for this, its x coordinate will be equal to ux into t. That means u cos theta into t. So this is the x coordinate at any time instant t. Now how to find its y coordinate? Y coordinate will be equal to uy t minus half gt square. So uyt is u sin theta t minus half gt square. Now from this equation, let me say equation 1 and let me say equation 2. From equation 1 we can say that t equal to x upon u cos theta. I will put this value of t in this equation. So what do we get then? Y equal to u sin theta into x upon u cos theta minus half g u cos theta x upon u cos theta whole square. So from this thing we can say x cancels out and in the end we will get y equal to x tan theta minus g upon x square. So this is the equation of the path on which the body moves. This is a parabola actually. The body takes a parabolic path and x coordinate and y coordinate can be found from this equation. Now in the beginning I had given this thing that y equal to u sin theta t minus half gt square. Now from using these equations we need to find out these things. First is time of flight. First is second is maximum height. Maximum height attained by the body, and third is horizontal range. Horizontal range means the body falls at some distance from the point of projection. So what is the distance of that point at which it falls? Horizontal range. So we have to find time of flight first, then this maximum height and then range of the projectile. Now to find out this thing, I will do one thing. In this equation we can put y equal to 0. Let us do that. U sin theta t minus half gt square equal to 0. When the body has landed on the ground, then it has been in the air for time of flight, capital T. It has landed. So after landing its y coordinate will be 0. If its y coordinate is 0, in this equation I can put that thing, and from here I will get two values of t. T into u sin theta minus half gt. So from this I get two values of t equal to 0 and t equal to 2u sin theta by g. So this is the instant when body has been thrown. When the body was thrown, its y coordinate was 0 and for that t was 0. When the body has landed, that means time of flight, that is given by this t, and at this instant body has landed. So this is my time of flight. So time of flight t equal to 2u sin theta by g. This is time of flight we have found out. Now we need to find out maximum height. How to find maximum height h? Actually, at maximum height, at this point, vertical velocity is 0, Vy equal to 0. So how to do it? Vy square equal to uy square minus 2gh. This thing is 0. So u square sin square theta minus 2gh. So from here h equal to u square sin square theta by 2g. So this is maximum height attained by the projectile. Now we need to find out horizontal range, the distance at which the body is falling from the point of projection. Let's find out that thing. Horizontal range r equal to ux into t. Ux is horizontal velocity with which it has been flying continuously. Horizontal velocity does not change with time. It is u cos theta in the beginning and u cos theta throughout and u cos theta in the end, and it is moving with that velocity for time of flight. So how much horizontal distance it has travelled in this time we can find out. So how to do? In place of this u cos theta and in place of this 2u sin theta by g. So this is 2u square cos theta sin theta by g. So from here we get u square sin 2 theta by g. So horizontal range is given by this. Okay. In this expression, maximum value of r max equal to what? When we get maximum horizontal range, when this thing sin 2 theta is 1. When sin 2 theta equal to 1. Sin 2 theta equal to 1 means 2 theta equal to pi by 2. Sin theta is maximum for sin 90 degree, that means sin pi by 2. So, 2 theta is pi by 2. So, from here theta equal to pi by 4. So, for maximum range we have to throw the body at 45 degree angle. For same velocity it will go at the farthest point if it is thrown at an angle of 45 degree. So, this is how to find maximum range in projectile motion. Now, next thing, here we have found that T equal to 2u sin theta by g, h equal to u square sin square theta by 2g, and r equal to u square sin 2 theta by g. Now, using these three equations, find h by r. What is h by r? We can find from here u square sin square theta by 2g, and this r g by u square sin 2 theta. So, we are left with sin theta square upon 2 into 2 sin theta cos theta. So, this sin theta goes away and we have tan theta by 4. So, from here we can say that tan theta equal to 4h by r. Note down this thing also. Now, we are going back to the equation of y. We had found that y equal to x tan theta minus g by 2u square cos square theta x square. So, from this equation we will do one thing. Y equal to x tan theta minus g by into x square. So, this is x tan theta minus in place of here we can put g into sin theta upon 2u square sin theta and cos theta x square. I have multiplied by sin theta. I have multiplied by sin theta in the numerator and denominator both. So, rest of the things are just little manipulation. So, now we can do one thing. X tan theta minus g sin theta by u square u square 2 sin theta cos theta into cos theta to x square. Now I will bring this g here and it becomes like this: x tan theta minus tan theta by u square sin 2 theta by g. This g is coming below here, below this thing, and this cos theta is remaining like this. Sin theta is here, so sin theta upon cos theta, tan theta. So the equation will be looking like this x square. So from here it becomes x tan theta minus tan theta x square by r. So now this equation can be further rearranged. So y equal to x tan theta. I am writing equation once again so that we can do further things, and then we have x square tan theta by r. So my equation becomes x tan theta into 1 minus x by r. This is also an important equation. This equation is useful when we solve JEE questions. For board exams it is not that important for 11th class, but for JEE this equation can be quite useful. Now x equal to u cos theta t and r equal to u square sin 2 theta by g. So I will use these two equations and find x by r. So x by r is equal to u cos theta t divided by u square 2 sin theta cos theta, and g comes here. So like this, and we have this thing, cos theta also goes out. So what are we left with? Equal to Tg by 2u sin theta. Now this equation can be written. This equation can be further manipulated slightly. T divided by 2u sin theta by g. So this is equal to, this is nothing but time of flight, this part. So t by t. So x by r. So the equations that we are getting now are like this. I will summarize at next page. X equal to u cos theta t, y equal to u sin theta t minus half gt square. Then t equal to 2u sin theta by g. H equal to u square sin square theta by 2g. Then r equal to sin 2 theta by g. Then this equation can be further developed into y equal to x tan theta 1 minus x by r. And in place of tan theta equal to 4h by r, and in place of x by r we can put t by t. So I will use these things in this equation. So y equal to 4h by r into x into 1 minus x by r. Then this can be written as 4h into x by r 1 minus x by r. Another equation. Then one more equation we can formulate is, in place of x by r, we can use this result. So y equal to 4h t by t to 1 minus t by t. So these are all the formulae as far as this projectile motion is concerned, and it will cover all the questions, possible questions up until JEE advanced level. So now we can take one question, we will try to take one question here. A body has been thrown like this. A body has been thrown like this, u and theta. After some time, it starts traveling in a direction perpendicular to the initial direction. The body is traveling perpendicular to the initial direction. After how long the body travels perpendicular to the original direction. This is the question. So this body initially thrown at angle theta with speed u. After some time, it is moving like this, and this angle is 90 degree. So after how long this thing happens? So we need to find that. Now how to do this thing? How to draw this question here? Actually, this is ux and this is uy. Now this ux will always remain same. Let me say v. So ux is always equal to u cos theta. Now from here, this angle is theta, this angle is theta, so this means this angle is 90 minus theta, and if 90 minus theta, that means this is also theta. So from here, v sin theta is equal to u cos theta. From this side, this is 90 minus theta, and cos component of v in this direction will be v sin theta will be equal to ux, and ux is u cos theta. So v sin theta is u cos theta. So we can find v equal to u cos theta upon sin theta. Now we have already found this thing, and from this thing minus v sin theta is equal to u sin theta minus gt. So in place of this we can put minus u cos theta by this is here the cos component here, v cos theta minus v cos theta equal to this thing. So in place of v we can put this value of v now here. So minus v into minus u cos theta by sin theta into cos theta equal to u sin theta minus gt. So from this minus u cos square theta equal to u sin square theta minus sin theta gt. So from this line I will take it this side and this thing to this side. So gt sin theta equal to u. So from here t equal to u by g sin theta. This is the answer. Okay, that's it. Thank you. Sir, देखो सर, ये एडिट हो जाएगा लास्ट वाला पार्ट.